Hey, what's up, guys? First off, hope everybody's had a great Easter. Hope everybody's staying safe and all that stuff. I want to say thank you for everybody that has turned your work in on time. I know that this is not the most ideal situation, but those of you that are turning it in on time, I'm doing my best to get it back to you quickly. I've got a lot of stuff coming in, and it takes me a lot of time to get through each individual assignment and give everyone feedback. I've been posting grades as quick as I can, so just keep everything rolling in. We have a ton of content to cover. This is typically the busiest time in chemistry. We're usually doing labs every couple days. We're knee deep in a lot of the heavy stuff, and so it pains me to know that we're not able to do that the way that I wanted to. So I'm going to do my best to give you guys the, the broad strokes on our content and make sure that you're exposed to as much as possible and as effectively as possible. So we're going to jump right in. I have to give you a disclaimer on this one. We're going to get into some math stuff. So you're going to need a calculator, and I hope you have those with you and they're not in your locker at school. If you don't have a handheld calculator, there are a lot of good websites there are online calculators that you can access. So if you need help accessing those or finding those, let me know and I'll get you squared away. So again, math stuff coming at you. Get your calculator and let's jump into it. So we're going to discuss a new topic. You may have heard of it in the past somewhat. We're going to be talking about the mole. And I'm not talking about the things on your arm or on your face. The mole in chemistry takes on a whole new definition. It's actually the metric unit for measuring amounts. In chemistry, when you think about the things that we deal with, we're dealing with atoms and molecules, and those things are really, really tiny. So when we are talking about those on a larger scale, we need a unit that allows us to talk about a lot of things in a very manageable way. And this "Hey Ladies" is coming in on a picture. Don't think I'm getting fresh there. So the mole is the unit for measuring a large amount of stuff in a very manageable way, so, as I already said. And when we talk about the mole, I want you to think about how we use the measuring unit of a dozen. Okay, so it's Easter. Everybody is dyeing eggs. And that dozen always equates to the number 12. So 1 dozen of anything equals 12 things. It could be a dozen roses, a dozen eggs, a dozen donuts. It could be a dozen elephants, a dozen monkeys, a dozen cars, whatever the case may be. A dozen always equals 12. And that's the way that the mole is in science and chemistry. We find that the mole was developed by this guy over here. He's a looker. Look at that guy. His name is Avogadro. Not avocado, but Avogadro. And here's his number that he came up with. It's a conversion unit. We call it Avogadro's number. And it is 6.02 times 10 to the 23rd. It's a very, very, very big number. So what this means is that 1 mole of anything is equal to 6.02 times 10 to the 23rd of those things. So just as 1 dozen of anything is equal to 12, 1 mole of anything is equal to Avogadro's number of those things. And because we've got the mole and Avogadro's number, we've got so many cool chemistry cartoons and memes that have come out of that. So I'll just let you look at those for a second. All right, so we're just going to jump right in and do some conversions. And before we do that, when we talk about the moles, we're going to also need to understand something called representative particles. Now, representative particles are just, as you see, the basic unit of each substance that we're dealing with. So we talk about elements, and if we're talking about elements, what's the smallest piece of an element that we're dealing with? Well, those are atoms. So the representative particle of an element is an atom. If we're dealing with covalent compounds, as we talked about weeks ago, covalent compounds, we deal with molecules. So the representative particle of a covalent compound is a molecule. And don't abbreviate molecule because you'll get it confused with moles. And lastly, if we're dealing with ionic compounds, the representative particle is called a formula unit. So the smallest singular piece of an ionic compound is a formula unit. So like sodium chloride, one formula unit of sodium chloride is going to be one sodium atom and one chloride coming together to make a single unit, a formula unit. And yes, formula unit is abbreviated FU. Yeah, so let's see what this looks like when we're talking about conversions. So I'm going to have to change my screen here, so if you don't see my beautiful face down there in the corner, just bear with me so I'm able to write. So what we have when we use Avogadro's number is it turns this equivalency, 1 mole is equal to Avogadro's number, it turns that into a relationship. And in mathematical chemistry, we like to write relationships as ratios and using like a fraction bar. So 1 mole of anything is equivalent to 6.02 times 10 to the 23rd of whatever it is that you're talking about. And we could flip that upside down and it still be the same because these things are equivalent. It's like if I took 5 over 5, well, that equals 1. So I could flip that over. It doesn't matter which 5 is on top because that's an equivalency. Okay, so what we do is we take this relationship and we use it to convert numbers of particles, represented particles, to moles, and then vice versa. Okay, so let's see what that is going to look like. So if we know that 1 mole is Avogadro's number, right? Boom. But what if I have a situation like this, and I have, I'm going to write this out in words. How many atoms are in 2.5 moles, and moles abbreviated is MOLS. It just drops the E. I don't know how much of an abbreviation that is. 2.5 moles of sodium. So how many atoms are in 2.5 moles of sodium? Now, first thing we want to pay attention to is the fact that we're asking about atoms because atoms is the representative unit of the element sodium. I don't say how many molecules are in 2.5 moles of sodium because that's an element, and elements have atoms as representative particles. Okay? So this is also where I bring back what I introduced way early in the year, our good friend the crossbar. And you guys have heard me preach about the crossbar. I literally every year have people come back to me and say, thank you for teaching me that crossbar. It has saved my butt in physics. It saved my butt in chemistry. I have people that I'm tutoring that want to know how to do it the way that I learned. So I am going to toot my own horn there a little bit. So just please buy into this now, and it'll reap benefits for you. So if you remember the way that we use the crossbar, we build this little, it looks like a half tic-tac-toe board or a goal post or something. And in this upper left quadrant, we put the information that we have or that is given to us. So the information that we have or that is given. And in this case, we're given 2.5 moles of sodium. And I'm going to write all of that information because it's extremely important. 2.5 moles of sodium. All right, that's the information that I'm given. And over here in the right, upper right section, it's not really a quadrant because there's more than 4, but this is where I put the information that I need. So the problem asks for how many atoms. And that's going to be atoms of sodium. Okay. So I've got what I've been asked to find over here in the need section, and over here is what is given to me. Okay. Now, before I work, and this is key, before I work with any kind of number, I start looking at the units that I'm given and that I need. And in this case, I'm given moles of sodium. That's the information that I know, moles of sodium. And it's over here. Now, ultimately, I've got to try to get away from that unit because I'm asked to find information in atoms. So what I'm going to do is I'm going to put that information, moles of sodium, down here on the bottom. Because what that's going to do is that's going to allow me, anything that's on top and bottom will cancel out. So that's going to allow me to cancel moles of sodium out and move away from that unit to try to get to the unit that I need, which is atoms of sodium. Okay, so now that I've put my units in there, I can put my numerical relationship and values. So what I just learned over here is that 1 mole of any substance, of anything, equals 6.02 times 10 to the 23rd atoms of that, or representative particles of that. So again, because we're dealing with an element, we're looking at atoms as the representative particle. So now my units, top and bottom, cancel. Moles of sodium and moles of sodium. And the only unit that I have left is atoms of sodium, which is what I need. Okay, so now comes the math, and this is where your calculator skills are crucial. Now, the way that we do this calculation is, change color here, is 2.5. Anything on top, we multiply across. So 2.5 times 6.02 times 10 to the 23rd. Now, this is where I'm going to caution you. When you put this in a calculator, you've got to put it in a very specific manner. Otherwise, it's not going to give you a correct answer. So here's how you need to key this in. You want to make sure that you use the parentheses on your calculator. Now notice this is in scientific notation, 6.02 times 10 to the 23rd. So you have to make sure that you can put in a number in scientific notation properly on your calculator. Okay? And every calculator is different, so I can't tell you how to do that. If we need to do a Teams video chat or a Zoom video chat or FaceTime or whatever, if you need me to look at your specific calculator, I'd be more than happy to do that. But that is crucial information. So the way that I would plug this in on the calculator, of course, 2.5, and then times, then I would open parentheses and then put in my scientific notation, 6.02 times 10 to the 23rd. Ever how you need to do that, and that's calculator specific. And then very important here, close parentheses. Okay? And then hit your equal sign. Now what that's going to do is that's going to calculate Avogadro's number first, then multiply it by 2.5, and then it's going to spit out an answer here. All right? So I'm going to do the same thing on right now. I'm going to pause, and then I'm going to do this on my iPhone calculator to see how it comes out. Alright guys, so I paused the video and I did the calculations. Now I want to point out, if you're going to use an iPad or an iPhone calculator, you need to turn it sideways to access the scientific calculator functions. And the way that you would enter this calculation in on that calculator is 2.5 times, then open your parentheses, and keying in scientific notation works like this: 6.02, and then instead of trying to do times 10 to the 23rd power, you hit EE. That EE means times 10 to the, so 6.02 EE 23, close parentheses, then hit equals. Okay, so practice that, pause the video, practice that, and you should get an answer of 1.5 times 10 to the 24th. Okay, now we're not looking at just round to the 10th place right here. Okay, we're not going to cross that bridge right now and worry about how many digits to round to. So then that's your answer up here. So 2.5 moles of sodium contain 1.5 times 10 to the 24th. If my pen will work. Atoms of sodium. Okay. So this was a problem that went from, notice, from moles to atoms. Moles to atoms. So this was from moles to the representative unit. So we're going to do a few more of these. Okay. And instead of writing out a full word problem right now, I'm just going to write out a couple example problems. Let's say we have one 3.04 times 10 to the 25th molecules equals how many moles of water. Okay, now first things first, notice that I used the formula unit molecule and my covalent compound of water. If this was an ionic compound over here, then this would be formula units. If this was an atom, or I'm sorry, an element over here, then I would be looking for atoms. But this is a covalent compound, so I'm looking for molecules. Okay, so let's get out our crossbar. The information that I have is here, 3.04 times 10 to the 25th molecules of water. The information that I need is over here, moles of water. Okay, so now that you place what you have and what you've been given, this is where you come down and you place the other units. So I'm needing to cancel out moles of water, or molecules rather, of water. So that goes here. I'm trying to get to moles of water, so that goes up here. Now, the numerical relationship between moles and molecules. Well, we know that there is one, for every 1 mole of anything, there's 6.02 times 10 to the 23rd formula units, or I'm sorry, representative particles of that. So moles to molecules. Okay. All right, so now when we're keying this one in the calculator, before we do that, we've got molecules, H2O there, molecules, H2O there. They cancel. So now we're in the unit that we're trying to get to, moles of water. So when we key this one in the calculator, it's going to look like this. This is actually a division problem. So we've got 3.04 times 10 to the 25th on top times 1, which we don't need to do, divided by, and that's what this big bar here means. Think of this as like a fraction. So that's divided by Avogadro's number on the bottom. So now keying this in the calculator, we've got 2 sets of parentheses that we're going to have to employ. So this is what that would look like. 3.0, or open parentheses, 3.04 EE, if you're using an iPad or iPhone calculator, 25, close parentheses. You got to close parentheses. Then hit your division bar. Division bar. Or division sign, rather. Okay. And then key in Avogadro's number by another open set of parentheses. 6.02 EE, scientific notation, and then 23. Close parentheses, then hit equals. Okay, I'm going to give you a chance to calculate that, and we'll see if you get what I get. Alright, after you calculated that, I got an answer of about 50.5. So 50.5 moles of water. Okay, so this problem was going from molecules to moles. Right? Be sure to go back and refer to these as examples when you're doing your practice, okay? And try to match up the problem type, whether it's moles to molecules or molecules to moles or atoms or formula units or whatever, okay? All right, we're going to move on to another aspect of this mole conversation. And notice that up to this point, we've not mentioned anything about mass. And this is where we're going to bring in the concept of molar mass. All right, now let's say that we had 1 mole of a substance. And let's say we've got 1 mole of carbon. Now, as we just talked about, that 1 mole of carbon is equal to Avogadro's number of atoms. Well, what if I was wanting to know, instead of atoms, what if I wanted to know in terms of mass? What if I wanted to know, okay, 1 mole of carbon is equals how many grams? Well, here is where we find out that information. If you remember, I gave you a list of elements and kind of resembled, not that, here we go, resembled this. And one side was in alphabetical order, the other side was by order of atomic number. All right. Now, up to this point, when we've looked at the periodic table and we've seen that mass unit down there, we've not really equated it to grams, but now we are going to. Okay, so what we find is that 1 mole of any substance or any element, 1 mole of an element is equal to its atomic weight or its atomic mass in grams. And it's really a pretty simple and straightforward concept, because now if I'm looking for the mass of 1 mole of carbon, I just go to the periodic table or this list and say, all right, I've got carbon right here. Here's carbon. 1 mole of carbon is 12.01. Now this particular table takes it way out to several decimal points, but if you look on a periodic table, you're going to see it's rounded to about the 100th decimal, so 12.01. So looking at carbon, 1 mole of carbon is 12.01 grams of carbon, and we refer to this as grams per mole. So grams per mole. So 1 mole of carbon, and remember we can write it as a relationship, 12.01 grams. Or they can be flip-flopped and say there's 12.01 grams for every 1 mole. of carbon. And there's several ways that you can see this written, but just know that the molar mass is technically grams per mole. And for carbon, it's 12.01 grams per mole. Now, looking back at this table, if you know the atomic mass, then you know the molar mass of every single element on the periodic table. So that being said, the molar mass for oxygen, you look it up on the periodic table, it is 15.99 grams per mole for oxygen. The molar mass of hydrogen, you'll do that one quite a bit. The molar mass of hydrogen, 1.01 grams per mole. All right. Okay, now let's look at a compound then. Let's say that we have a compound like water. If I'm trying to calculate the molar mass for water, let's just write that down in words. Calculate the molar mass of water. Okay, so we have to analyze the formula. Now, water, of course, is H2O, so that means that there's 2 atoms of hydrogen and 1 atom of oxygen. Well, now we can view that in a little bit different way. Instead of saying that there's 2 atoms and 1 atom of oxygen, 2 atoms of hydrogen, we can look at this as the number of moles of the element in that compound. So there are 2 moles of hydrogen in 1 molecule of water. There's 1 mole of oxygen in 1 molecule of water. Okay? So if I were going to calculate the molar mass, I need to calculate the mass of all of the moles that are in this molecule. So when I look at hydrogen, the molar mass of hydrogen is 1.01 grams, right? But we've got 2 hydrogens, 2 moles of hydrogens. So we're going to multiply that by 2 and get 2.02. So I've got 2.02 grams worth of hydrogen in 1 molecule of water. All right, for oxygen, I'll look on the periodic table, and oxygen has a molar mass of 15.99 grams. And I just have 1 of those. So when I add that together, I get what is generally accepted as 18.02. If you spend any time in chemistry, you will come to memorize that. So 1 mole of water has a mass of 18.2 grams. That's the same thing as saying that the molar mass of water is 18.02 grams per 1 mole of water. All right. So calculating the molar mass is really just, it comes down to adding up the mass of all of the elements in a compound. So if I were going to calculate the molar mass of copper sulfate, okay, so looking at just the formula, I've got 1 mole of copper here, just 1 mole of copper, and that 1 mole of copper has a mass of 63.54. Okay, I've got 1 mole of sulfur in that compound, and that 1 mole of sulfur down here, 32.06. Okay, oxygen, however, I want to round it to 16. It's 15.99 from here, if you notice, 15.99. So I'm just going to round it to 16. But I've got 4 moles of oxygen in this compound, so that's going to give me a total of 64. All right, so I'm going to add the 64, the 32.06, and the 63.54 together. And let's see here. Having some technical difficulty. I'm going to pause and then add that together. Alright, so I added it up and I got a mass of 159.6. Yeah, just 159.6. So the molar mass of copper sulfate is 159.6 grams per mole. So you could write it like that with the grams per mole unit, or if we're using this in a problem, as you'll see here shortly, you could write it like this: 1 mole of copper sulfate, 159.6 grams. So we refer to this method, we call that a conversion factor, because we use that in formulas. So let's see how that looks in a formula. So what if we have a question that asks this? How many grams are in 7.4 moles of methane? How many grams are in 7.4 moles of methane? Alright, so I go straight to my crossbar here. And I look to find the information, as always, what is given to me in the problem. And typically it might be in the very end of the problem. So 7.4 moles of methane, that's a CH4 over there. And I write the entire thing, 7.4 moles of methane. All right. Now, on this upper right, I'll write the information that I'm being asked to find. How many grams are the information that I need? So, grams of CH4. Okay. Now, here's the one thing that you've got to lock in on when you're doing these conversions. Because we started this conversation of the mole, we were talking about Avogadro's number. Many people will look at this and say, oh, okay, I've got moles here, so that means I've got to stick in Avogadro's number right here. You only use Avogadro's number, now hear me out. You only use Avogadro's number when you are converting to or from the number of particles, whether it's atoms or molecules or formula units. If you are converting to or from grams, you don't use Avogadro's number initially. Now, we may have problems where grams are a part of the problem, and we use Avogadro's number at some point. But in a situation like this, where we're trying to find mass and we're given moles, there's no in-between step. We just use the molar mass from the periodic table. Okay, so when you see mass, ding, 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 think, okay, molar mass, periodic table. That's where I find that information. Okay, so now, let's place our units. Moles are over here, so I know that I want to cancel those and get rid of them, so I'm going to put them down here on the bottom. Grams are on the upper right over here, so that's what I'm trying to get to. So I'm just going to abbreviate grams, G, and I'm putting my methane in there. Try to get in that habit of where you write all this information. Just trust me, because we're going to be doing long problems where you're going to have other compounds in there, and if you didn't write CH4, you don't know which compound you're talking about. Okay, so now we got to put our numerical information. So this is where you may have to come off to the side and do a little bit of calculation. Okay, so I'm looking at a relationship between moles and grams. Now, I know that I get that information from the periodic table, so I've got to calculate the mass of CH4. I've got to calculate the molar mass of CH4. So I have to come down here and say, all right, for carbon, I've got one carbon atom, so carbon has a mass of 12.01. Okay. For hydrogen, hydrogen has a mass down here, and you will memorize a lot of these. 1.0007, well, we generally round that up to 1.01. But we've got 4 of those in methane. So that equates to 4.04. So collectively here, I've got a mass of CH4 of 16.05. So that's where my 12.01 from carbon added to my 4.04 from hydrogen. So 16.05. Now, this is for 1 mole of CH4. Anytime you're dealing with molar mass like this, it is always for 1 mole of that substance. 1 mole of that substance. 1 mole of methane, CH4, contains 1 carbon and 4 oxygens for a total of 16.05 grams. Okay, so now at this point, we can actually do our calculation up here. So our moles units cancel top and bottom. We are now in grams of CH4. That's where we want to be. So now it's multiplication. 7.4 times 16.05. We crunch that number really quickly. I'm working on my iPad over here to the side. And I get 118.77 grams of methane. Okay. So this was a mass to mole conversion. Let's do one where we're going from moles to mass. All right. How many? Let's see what I do. How many moles of, say, let's pick a compound here, let's say ammonia. How many moles of ammonia are in 77.5 grams of ammonia? Right. So if you have 77.5 grams of ammonia sitting in a jar, how many moles of ammonia do you have in that jar? Okay, so like always, we're going to start with our crossbar. I'm asked, or I'm given this information, grams of pneumonia. So 77.5 grams of NH3. And this is ammonia, not ammonium. And I am asked to find moles of ammonia. Okay, so I'm going to place my units over here. I need to cancel grams of ammonia and move to moles of ammonia. All right, so in order to do that, this numerical calculation or value and relationship over here, for every 1 mole of ammonia, I've got to find the molar mass. Where do I do that? I find the molar mass from my periodic table. Okay, so in 1 mole of ammonia, I've got 1 nitrogen in there that's going to be 14, disappeared on me, cover it up, 14.01 is what is generally accepted grams. Now I've got 3 hydrogens. Remember, hydrogens is 1.01, but I've got 3 of them here. So 3.03 grams of hydrogen total. So together, collectively, my molar mass for ammonia is going to be 17.04 grams per mole. So for 1 mole of ammonia, it's 17.04 grams of ammonia. Okay, so now my units here cancel. Grams of ammonia cancel with grams of an ammonia. Not pneumonia, ammonia. Oh, Lord help us. All right, so now mathematically, this is a division problem. I've got 77.5, technically times 1, divided by 17.04. So when we come off to the side and we crunch those, 77.5 divided by 17.04 equals 4.5 moles of ammonia. Okay. Okay, guys, so I paused the video just so I could type this out to save a little bit of time. Thank you for hanging in there with me. Now, this last problem example that I'm going to give you is one where we combine a few steps. Now, before, in these other problems, these examples, we started off with Avogadro's number, and we were converting formula units, atoms and molecules, and if we didn't have any kind of mass in these problems. Then we moved on to molar mass, where we started incorporating grams, and we got that information from the periodic table. And I made the point that anytime we are converting moles to grams or grams to moles, we don't use Avogadro's number just in that single conversion there. So notice Avogadro's number, the 6.02 times 10 to the 23rd, did not come into play there because we're not looking at the number of particles. We're just strictly talking about mass. Okay, now we're going to kind of bridge the two. So here this problem says how many formula units are in 6.3 grams of sodium chloride. All right, so if I were just looking at the relationship between mass and moles, I wouldn't need Avogadro's number. I would just do the conversions like in these examples. But because I'm asked to find how many formula units, Avogadro's number is going to come into play here. And also notice that it's formula units that I'm asked to find because I'm dealing with an ionic compound. If this compound were covalent, I would be asked to find how many molecules. Or if this was just an element, if this was sodium by itself, I would be asked to find how many atoms. Okay, so here's how this would set up in our crossbar. Okay, I want to give myself plenty of room here. And I suggest you guys do the same. Again, as always, in this step number, this never changes. In this top right or top left, I'm going to put the information that I'm given. So in this case, 6.3 grams of sodium chloride. In the right, I'm going to put the information that I'm needing to get to, or that I'm trying to find. And that's formula units, so there's the abbreviation FU, yeah. Sodium chloride. Okay, so now, I don't have a single conversion that would take me directly from mass to a representative particle, okay? So what I first have to do is convert this mass to moles, and you will hear that time and time again in chemistry problems. You always try to get things converted to the mole amount in order to convert it to something else. It's kind of a common intermediate. So what I'm first going to do here is I want to convert the grams of sodium chloride, so I want to get away from that. Eventually I'm trying to get to formula units of sodium chloride. So I want this to cancel the grams of sodium chloride, and I'm going to take it first to moles of sodium chloride. Okay, so grams to moles. So let's go ahead and put that information in. And as always, anytime we're dealing with grams and moles, we get that information from the periodic table or from this list that you have. Okay, so, and it's always 1 mole of a substance when we're dealing with molar mass. So 1 mole of sodium chloride equals how many grams? Well, we have to calculate that. Sodium, 1 mole of sodium equals, oh, this is alphabetical. Sodium, 22.99. 22.99. Chlorine, we've got 1 mole of chlorine, and I know chlorine is 35.45. Let's just double check that. Chlorine, here, 35.45. So we add those together really quickly. And that gives us 58.44 grams in every mole of sodium chloride. 58.44 grams. Okay. So if I were to stop the problem right there, I would cancel grams of sodium chloride, cancel grams of sodium chloride. I would do my math, and then my answer would be in moles of sodium chloride. But I'm not asked to find moles of sodium chloride. I'm asked to find formula units. Okay, so I've got to take it a step further. So now I canceled the grams of sodium chloride unit, and I'm in the unit of moles of sodium chloride. Well, I can't stop there. I'm on a journey to get to formula units of sodium chloride. So I've got to come down here, and I'm going to put moles of sodium chloride on the bottom because it's on top here and I need it to cancel. And I'm moving from moles of sodium chloride to formula units of sodium chloride. Okay, so now let's analyze this relationship. Way back here at the very beginning, we said that ionic compounds deal with formula units, and 1 mole of anything is 6.02 times 10 to the 23rd formula units of that if we're talking about ionic compounds. So at this point, this is where I would bring back in Avogadro's number and say 1 mole of an ionic compound like sodium chloride contains 6.02 times 10 to the 23rd formula units of that compound. Okay. So now I've got all my information in place. Moles of sodium chloride cancels with moles of sodium chloride, and I'm left with the unit that I'm trying to get to. Okay, so now how I would key this in the calculator. Again, calculator skills are very important at this point. So I would have 6.3 times, open parentheses, 6.02. If I'm doing this on iPad calculator, EE. If you're doing it on another calculator, you might just hit times 10 raised to the 23rd power. Okay, now when you have numbers on the top and the bottom here, you have to do everything on top first and then get an answer. Okay, so I'm going to pause and I'm going to do that and get that calculator. Okay, that gives me an answer of 3.79 times 10 to the 24 on top. Then you take that top number and divide it by what's on the bottom, 58.44. And that gave me an answer of 6.5 times 10 to the 22nd power. Okay. And that wraps it up. All right. Now, you're going to have some practice problems that resemble these. they might look a little different in terms. Not every practice problem is going to ask you for formula units and grams. It might ask you, if you're given, it might give you the represented particles and ask you to calculate the mass. Okay, but try to follow these examples that I've given you. And I cannot stress enough, guys, to reach out to me if you have a problem with one of these, because I can do straight up Zoom meeting, and I can share my screen and we can walk through it together. Okay, so please take advantage of that. And I'm going to cut it off for now, and just keep me in the loop, communicate with me, please, and I hope you guys stay safe, and we'll talk to you soon. See ya.